Hello, welcome to the fifth video in the series of video on current electricity. In this video we're going to talk about Ohm's law. Ohm's law was experimentally found out by George Simon Ohm. So he basically studied the potential drop across a resistor and the current. He tried to find out if there is any relationship between the current and the potential drop for a given resistance. And to his surprise, he found out that the voltage and the current were always the ratio was a constant. So this is what he discovered. Now what this means is let's try to make an empirical sense of what it means. So your current is basically your coulombs per second or amperes. So if more number of coulombs are passing through this resistor every second, then of course there is going to be a lot more, you can expect a lot more collisions of those electrons which actually go in the opposite direction. So there is a lot of energy dissipation, and hence this quantity will be very high, which is the energy lost between these 2 points for every coulomb of charge that passes through the resistor. So in other words, the potential drop across the resistor is quite high if the current is high, and if the current is low, then the potential drop will also be low because there is lesser number of coulombs passing every second. So this constant is what we call as the resistance, or denoted by R, and the unit, the SI unit is ohm, in memory of George Simon Ohm, who found about this relationship. So we can say that V is equal to I into R, and if you develop a feeling for this equation wherein this represents coulombs per second, how fast the charge moves across a resistor. So if this I is quite high, then the V will also be quite high. So if you develop this feeling, it will kind of stick onto your head. So we have an experiment that we have to do in our class, which is verification of Ohm's law. Now there is a video which has been recorded on this experiment, but in this video let me run you through what we do in this experiment. So in this experiment, you take a resistor and you try to pass currents, various currents, values of current through the resistor. Now to measure this current through the resistor, you put up an instrument called ammeter. So this is called ammeter, right? And to measure the potential drop across the resistance, you put up an instrument called voltmeter. Now why do you connect this voltmeter in parallel? Because you need to find the potential difference across these 2 points. And what you will do is you will measure for various values of current what is the value of the potential drop across the resistor. Now how do you pass varying current? To pass a varying current, you connect a battery and you connect something called rheostat. Now this rheostat is something called this is called rheostat, denoted by RH, and this is your battery, which is denoted by B. So this unit is, you can say this is more like your current regulator. So this is your current regulator. This is exactly how your fan regulator works. As you turn the knob, you're changing the resistance. So does a rheostat. and that changes the current that is supplied to your circuit. So we set this up, and then we connect this to your circuit, and then you record various values of I and V. So let's say, let's say the resistance is a 6 ohm resistance. So for varying values of current, you should get a voltage which is equal to I into 6. So for, let's say, for 0.25 amperes, you may get 1.5 volts of potential drop. So you pretty much from this reading, from this one reading, you can find out what your resistance is. Your resistance is 1.5 divided by 0.25, and that will be equal to 6 ohms. But usually when you do experiments, there are experimental errors, so you won't get exactly 1.5 volts. You may get maybe 1.4 or 1.6. So the way to do is you calculate these values for additional 4 or 5 readings. You find out the current and the voltage. So let's say these are the readings. So here are the 5 readings or 4 readings for voltage and current across the resistance of 6 ohms. And for each of this, we can find the resistance. Each case, the resistance would be V by I, and you find that the resistance remains the same. What changes is the current and the voltage. So we can draw a VI graph for this particular data. So you have V as in volts and I amperes. And what you will find is that the VI graph gives you a straight line, and all the points ideally needs to be will be all in this line. Once you find the slope, plot this straight line, you can find the slope of this line, and that slope of this line will give you the resistance. That's another way of telling Ohm's law, which is your slope of VI graph, it gives is equal to resistance, and it can be expressed as delta V divided by delta I. Now usually you may be thinking, why do you need to plot these points and get a graph, etc., when you can straight away get R is V by I, and maybe you could even do an average and say that's 6 ohms. Well, that's true, but when you do experiments, what happens is these values of R may not be exactly 6 ohms. So these could be let's say 5.9, 5.7, 6.1, etc. So what happens is you plot these points and you draw a best fit line. So this line becomes your best fit line, and a best fit line is a line which has same distribution of points above and below. So the distribution is quite even across the points. So you can draw a best fit line and find out the slope for it. So it's quite handy when you do experiments. So here is Ohm's law in a nutshell. Ohm's law says that, well, if you have a resistor and the potential drop is V across it, and the current that passes through is A or I, then V by I equal to R. So that's what Ohm's law says, and it also says that the slope of VI graph will be equal to resistance. So I hope you enjoy this video. I'll see you in the next one. Thank you.